In 2003, the Concorde made its final flight, marking the end of an era where you could fly from New York to London in under 3 hours. Most people assumed it was over. Too expensive, too loud, too ambitious. But what if they were wrong? A mysterious startup backed by hundreds of millions of dollars says supersonic travel isn't just coming back. It's coming back faster, cleaner, and cheaper than ever. And they've already built a jet that just broke the sound barrier. This isn't science fiction. It's already happening. So what exactly is Boom Technologies' baby boom? Can their Overture airliner really change the future of flight, or will it crash and burn like every attempt before it? Let's find out. For decades, the Concorde was the crown jewel of aviation, a sleek, needle-nosed rocket slicing across the sky at over Mach 2. It could outrun the sunrise, cross the Atlantic in 3 hours, and made flying feel like time travel. But behind the glamour was a brutal reality. The Concorde was insanely expensive to operate, required constant maintenance, and drank fuel like a jet-powered monster. Then there were the sonic booms, so loud they shattered windows and triggered noise bans across continents. Politicians hated it. Environmentalists feared it. Airlines couldn't afford it. By the early 2000s, one crash, rising costs, and global pressure buried supersonic travel for good, or so it seemed. But not everyone was ready to give up on speed. In 2014, while the world was obsessing over electric cars and Mars missions, a small team in Denver had a crazier idea: bring back supersonic passenger flight. But this time, make it smarter, cleaner, and actually affordable. The company? Boom Technology. No flashy government contracts, no legacy aircraft factories. Just a group of engineers, a garage-sized office, and an obsession with speed. By 2016, they got accepted into Y Combinator, the same startup accelerator that helped launch Airbnb and Dropbox. Investors started to take notice. And by 2019, Boom had raised hundreds of millions of dollars. Their dream: a supersonic airliner called Overture, built to carry passengers at nearly twice the speed of sound. But before they could build that, they had to prove one thing: that they could actually break the sound barrier. That's where Baby Boom comes in. Officially, it's called the XB-1, but everyone in the industry knows it by its nickname, Baby Boom. At first glance, it looks like a miniature Concorde. Same pointed nose, same sleek frame. But make no mistake, this isn't just a tribute. It's a weaponized testbed for the future of commercial aviation. The XB-1 is a one-seater, built not for passengers, but for data. Packed with sensors, telemetry, systems, and high-tech equipment, its job was to prove that Boom's technology could actually fly. And fly fast. It's about 68 feet long, less than half the size of Concorde, and with a wingspan barely a quarter as wide. But the size isn't what matters. What matters is what's under the hood. One major difference: the nose. While Concorde needed a drooping nose for landing visibility, Baby Boom uses a more modern solution: fixed nose design with camera-assisted taxiing. Less moving parts, less complexity, and better visibility thanks to smart sensors. In every way, this plane is built like a leaner, meaner descendant of the Concorde. But to survive supersonic speed, it needed more than just brains. It needed a body that could take the heat. Flying faster than sound isn't just about speed, it's about surviving a hellish environment. At Mach 2, the air friction alone can heat the skin of a plane to over 300 degrees Fahrenheit. Most commercial jets would literally start to melt, so Boom went to work. The XB-1's frame is built with advanced composites, carbon fiber for strength without weight, titanium for heat resistance, and stainless steel in the hottest zones. The tail alone? 90% titanium. Even the nose and wing edges, where heat hits hardest, were crafted with specialty materials from a Dutch firm called 10K Advanced Composites. Everything was engineered not just to survive, but to perform. Inside, the structure had to be ultra-light but rock-solid. The glider sections used intermediate modulus carbon fiber, while the wing spars were reinforced with high modulus variants designed to handle incredible stress. This wasn't a test plane built for show, it was a high-speed lab designed to push limits. Now all it needed was thrust. Speed like this doesn't happen quietly. Baby Boom is powered by 3 General Electric J85-15 turbojet engines, the same kind used in military fighters like the F-5 and the T-38 Talon. These aren't commercial engines. They're battle-tested beasts designed for raw thrust and high performance. With over 12,900 pounds of total thrust, the XB-1 isn't just fast, it's violent. It can hit Mach 2.2 and cover 2,000 miles in a single stretch. These engines don't just push the plane, they carry decades of supersonic heritage. But what's even more impressive is how Boom plans to evolve from them. Because Baby Boom was only step 1. The real revolution? That's coming with the Overture, and it's unlike anything the world has seen. If Baby Boom is the demo, then Overture is the headline act. This is Boom's full-sized airliner, 201 feet long, a 106-foot wingspan, cruising at Mach 1.7. That's nearly twice the speed of today's fastest commercial jets. Unlike the XB-1, Overture will have 4 engines, Boom's custom-designed Symphony engines, developed alongside aerospace heavyweights like GE Additive and Standard Aero. Together, they'll produce over 140,000 pounds of thrust. But here's where it gets crazy. Overture is built to be 100% compatible with sustainable aviation fuel. It's designed to meet the strictest noise and emissions standards in the world. This isn't just a fast plane, it's an environmentally conscious one. And the numbers? Wild. NYC to London in 3.5 hours. San Francisco to Tokyo in just 6. 500 plus potential routes worldwide with minimal carbon footprint. The goal? Mass production. Boom's super factory in North Carolina is aiming to build 100 jets per year. But it's not just airlines placing orders. Boom already has 146 orders lined up, from giants like United Airlines, Japan Airlines, and American Airlines. That's without a single commercial flight. But the most unexpected customer? The US military. In 2022, Boom announced a partnership with defense contractor Northrop Grumman to create special versions of Overture for military use, like rapid medical response, reconnaissance, and supply delivery. Supersonic speed isn't just a luxury anymore. It could save lives or change how nations respond to crises. But while the orders stack up and the factory hums to life, the real test came in the sky. Boom technology is promising to do what no one's done in over 20 years. Bring back supersonic passenger flight, and this time do it right. With a working prototype, a packed order book, and a clear roadmap, it's easy to believe the hype. But this is aviation, and aviation doesn't forgive mistakes. So the question is, will Overture really take off by 2030, or will it crash into the same wall that grounded the Concorde? Drop your predictions in the comments. Is this the future of flight or just another high-speed dream? If you enjoyed this deep dive, hit that like button, subscribe for more stories like this, and turn on notifications so you never miss what's coming next. Thanks for watching. See you in the skies.